Now here's an Edexcel Fp2 Transformations in a complex plane problem. There's a little bit of everything here. We're going to use some argument properties, we're going to use some modulus properties. It's almost like a couple of bonus marks once we've done that for some sketches after we've actually done the main work. So the meat is, if you like, on part A and on part B. Okay, so I'm going to use argument properties here, but in order to get this, because I've got argz is equal to pi by 4, and I can't just easily use that without making z the subject to the formula. So I'm going to do that quickly now. Times it over wz plus wi is equal to z plus 1. Wz minus z is equal to 1 minus wi. Z is equal to 1 minus wi over w minus 1. So we're told, let's write it up here, the argument of z is equal to pi by 4. So we've now got z in terms of w, so we can write our argument of 1 minus wi over w minus 1. Okay, so here equals to pi by 4. Here might look a bit unpromising because you don't really know what to do with this top bit with the wi, but we do know this property about argument of z minus z1 over z minus z2 equals to alpha actually gives us a circle. Okay, so we do know that. So if we can try and get it to that, unfortunately we've got an I there, so you can probably just times by an I or divide by that. It's times by an I on top and bottom just to get rid of it. So we've got I over I, 1 minus wi over w minus 1 equals pi by 4. That's going to give me argument of w minus plus I over, now it might look a bit unpromising here, but I've got that over w minus 1. Let's times that by 1 over I. Let's leave the, instead of multiplying it out, because that would be kind of counterproductive, because I would then have w on the I at the bottom, so that's not what I want. So now I'm going to use argument properties. So we've got argument of w plus I over w minus 1 minus argument of I is equal to pi by 4. Now the argument of I, as we'll see, is pi by 2. So we've got argument of w plus I, w minus 1, plus pi by 2 is equal to pi, minus pi by 2 is equal to pi by 4. Okay, well this is looking like argument of w plus I over w minus 1 is it equal to 3 pi by 4. Now you might think, oh well, we're trying to get it to a circle, but let's think about this for a second. If we were to now sketch this, we've got it's going from anti-clockwise from top to bottom, so it's going anti-clockwise wi from minus I anti-clockwise to plus 1, right? With this angle here being 3 pi by 4. Actually, it's the other part, isn't it? It will be actually, just thinking about it, it's going anti-clockwise from the plus I, now that's there, to w plus 1, that's there. I've got exactly the wrong half of it there. So that's equal to that, and we've got the 3 pi by 4 refers to this angle here. So we've done a little bit more than we needed to here actually, because it only asks for the part of the circle. Now we can see that this has radius 1. But we've actually got a little bit more detail than the question asked. There is an alternative way to this where you could just shove it in and work with the line with more standard ways. But I think using modulus method actually works quite nicely here. So we've got circle part, it's really part of circle. Mod 1. So that's quite nice. Okay. The advantage of doing this now, of course, is that we've now got the rearrangement for it. So if I stick in part B, we've got the modulus of z is equal to 1. So we can say 1 minus wi over w minus 1 equals to 1. So 1 minus wi over w minus 1. Again, I'm using modulus properties here, that namely that z1 over z2 or w1 over w2 is equal to mod z1 over mod z2. Okay, so that's equal to 1. So we've got 1 minus wi equals to mod w minus 1. And then we can multiply by I, because that doesn't change the truth of this, because that's just basically multiplying it by 1. I can multiply it by anything which has got a modulus of 1, can't I? It's still going to be true. So that's going to be I plus w is equal to w minus 1. You may think that this is taken, because we've got it, haven't we? We've actually got our line, because that is the perpendicular bisector of the points joining minus I and plus 1. So it's basically, it's a bit unfortunate, it's not gone through the centre, but never mind. Try better next time. There we go. So basically, the actual equation of that is u is equal to, or v is equal to minus u, or u equals minus v. Have we done it? It says, sketch on a separate diagram, or it says, find the image of this in this plane. So there we have it. It's u, v is equal to minus u. So we've done that. Seemed as though there was almost more work on the first half than the second half here, even though we only had 4 and 6. I think because there is an alternative to the first method without using argument properties. It might have been a little bit quicker, but the advantage is we've actually got the rearrangement already as well, and this has gone up to help us do this. Okay, so we're almost on part C here. So here's our Z plane and here's our W plane. We've already sketched the Z plane and here, so for our W plane, so I meant the other way around, of course. We've actually sketched the image with the original locus. Is something like that, mod Z equals to 1. So that's our kind of bonus mark for part C. For part D, it says mark on your sketch the point P where Z is equal to I. Right, okay, not a problem. Yeah, let's do it in red. Just that's Z equals to I. There we go. And then it says, and its image in our diagram. So if we put I into our original, into this here, we have Z plus 1, so it's I plus 1 over Z plus I, so that's over I plus I. So that's equal to I plus 1 over 2I multiplied by I on top and bottom. So we end up with -1 plus I over -2. So that gives us half, and then plus half, and minus 1 over 2I. So that point there, let's mark it. Mark the point P. Let's do what it says. Part P, and then it says image Q under the transformation is going to come somewhere like that. That's our Q, which is at half minus half I, which is represented by QW. Q is equal to, let's do that, faffing about a bit there. So Q is equal to half minus half I. So there we have it. Now, for those of you who look at a mark scheme, I'm not sure that this is what the mark scheme has done, but it's actually in many ways more sophisticated because we've got more details, so I've chosen to do it that way. Okay, there we go.